Today we are going to solve exercise 3.3 of calculus with analytic geometry that is written by SM Yusuf and Muhammad Amin. Exercise 3.3, evaluate given limits, problem 1 to 48. Before evaluating all these points of exercise 3.3, we must know one important thing that will come in this exercise, that is that exercise is basically depending upon the limits of indeterminate forms. In this exercise, basically we have to calculate the limits of some functions, and that limits are basically applied on the indeterminate forms. Now we must know that what indeterminate forms are. There are some examples for the indeterminate forms that are 0 by 0, infinity over infinity, infinity minus infinity, 0 raised to power 0, 1 raised to power infinity, infinity raised to power 0. This is a wrong conception that 0 divided by 0 is equals to 0. This is wrong. Basically, 0 divided by 0 is an undefined form. This is an indeterminate form. We cannot solve them. We cannot evaluate them. And similarly, infinity by infinity, infinity minus infinity, 0 raised to power 0, 1 raised to power infinity, and infinity raised to power 0. We cannot evaluate these undeterminate forms. So for solving these indeterminate forms, or for applying the limits on these indeterminate forms, we must know the L'Hopital rule. We will use this L'Hopital rule to evaluate the limits of indeterminate forms. In this L'Hopital rule, this thing will be clear into the exercise questions, but here is a small review of it, that L'Hopital rule, in what we will do in this L'Hopital rule. We will basically evaluate the limits of a function that come into the 0 over 0 form or infinity over infinity form. We will apply the L'Hopital rule on them. And for that purpose, basically we will have two functions in a fraction form, like f of x over g of x. We will differentiate f of x separately, and we will differentiate g of x separately. For example, there is some limit applying on, like for example, we have limit x approaches to 0. And this thing f of x over g of x, when we put 0 into this fraction, we get 0 over 0. If we get 0 over 0 form, then we will use the L'Hopital rule to evaluate the limit. For that purpose, basically we will do what? We will take the derivative of the numerator separately and the derivative of the denominator separately, and then we will evaluate the limit on it. So basically this is the L'Hopital rule, that we will take the derivative of the numerator and derivative of the denominator, and then we will apply the limit. Basically this derivative is doing what? This derivative is reducing the function. So differentiation is basically the reduction of the function. So that differentiation will help in solving our problems for finding the limits of a function. Exercise set 3.3, evaluate the given limits. The first question is limit x approaches to 0, e raised to power x minus e raised to power minus x over sine of x. Here the limit x is approaching to 0. If we put 0 in place of x, like we must check by putting it, e raised to power 0 minus e raised to power minus 0 over sine of 0. This will be equals to e raised to power 0 is 1 minus e raised to power minus 0. Minus 0 will be equals to 0. So e raised to power 0 will be again 1. Sine of 0 is 0. So you see here we got 0 by 0 form. So here we have 0 by 0 form. So we must use the L'Hopital rule to evaluate this limit. For that purpose, applying, or you can say like using L'Hopital rule, what you have to do in this, simply write the limit as it is, limit x approaches to 0, then take the derivative of the numerator separately and the derivative of denominator separately. Or you can say differentiate numerator separately and differentiate the denominator separately. This is a fraction form. Now I am differentiating numerator. Don't use the quotient rule of differentiation here. We cannot differentiate it as one function. We have to differentiate numerator separately and differentiate the denominator separately. And keep it at their own places. Now differentiating the numerator, e raised to power x, differentiation of e raised to power x remains e raised to power x, minus differentiation of e raised to power minus x will be e raised to power minus x, and the differentiation of minus x will give us minus 1. Differentiation of sin x will be cos of x. Now just rearrange it, e raised to power x minus minus plus e raised to power minus x over cos of x. Now apply the limit on the function. Just substitute 0 in place of x. We will get e raised to power 0 plus, here we have e raised to power minus x. This can be written as 1 over e raised to power x. This is a negative power. We can make this negative power as positive and it will become 1 over. We will just take the reciprocal of it and we will just make the power as positive, 1 over e raised to power x. So here we will get 1 over e raised to power 0 over cos of 0. E raised to power 0, anything having power equals to 0 will always give you 1, plus 1 over 1 divided by, here we also have to put 0, so cos of 0 will always be 1. So you get 1 plus 1 over 1, that is equals to 2. Now move on to the question number 2, that is basically question number 2. Limit x approaches to 0, e raised to power x square minus 1 over cos of x minus 1. If we put 0 in this function, we get e raised to power 0 minus 1 over cos of 0 minus 1. This will be equals to 1 minus 1 over 1 minus 1. So we again got 0 by 0. So this is basically 0 by 0 form. So use the L'Hopital rule here. Using L'Hopital rule. Differentiate the numerator separately and differentiate the denominator separately. Keep limit as it is. E raised to power x square. The differentiation of e raised to power any function is the same as it is, and then we have to take the derivative of this power. Derivative of this power x square is basically equals to 2x. Minus derivative of 1 is 0 divided by cos of x will be minus sin of x minus 1. We got limit x approaches to 0, 2x e raised to power x square over minus sin of x minus 1. Again, if we put x equals to 0, we will again get here 0 by 0 function, 0 by 0 form, indeterminate form. Because 2 into 0 will be 0, 0 into this any function will be 0, sine of 0 is 0. So, differentiation of 1 here will be 0. This is a mistake here. So, we'll just replace it with 0. So, minus sine of 0 will be 0. We will get 0 by 0 form. Now, again use the L'Hopital rule. Again using L'Hopital rule. Limit x approaches to 0. Now, here we have function in the multiplication form. So we'll use the product rule here in the numerator, 2 separately. x as it is. Derivative of e raised to power x square will be e raised to power x square, and derivative of x square is 2x, plus e raised to power x square, and derivative of x will give us 1, divided by derivative of minus sin x will be equals to minus of cos x. Now simply we will get limit x approaches to 0. Here we will get 4x square e raised to power x square plus 2 e raised to power x square divided by minus cos of x. Now put the limit here. We get 4 into 0 e raised to power 0 plus 2 e raised to power 0 divided by minus cos of 0. We get 0 into 1 plus 2 into 1 divided by minus 1. So we will get 2 over minus 1, that is equals to minus 2. Now move on to question number 3. Question number 3 says, limit x approaches to 0, x minus tan of x over x minus sine of x. If we put 0 in this function, we will again get 0 by 0 form. So we will use the L'Hopital rule and we will differentiate the numerator separately and denominator separately using L'Hopital rule. Limit as it is. Take the derivative of numerator. Derivative of x will be 1 minus derivative of tan x is secant square of x divided by 1 minus cos of x. Again here, if we put the value x equals to 0 in this function or we apply the limit, we will again get the indeterminate form, that is 0 by 0. So again using L'Hopital rule, we will get limit x approaches to 0, derivative 1 will be 0 minus power down, power minus 1, then derivative without power. Derivative of secant x will be tan x. Secant x, tan x, secant x, this one. Divided by derivative 1 is 0, cos x is minus sine of x. Now just simplify it. We will get limit x approaches to 0 minus 2. We will get here secant x multiply with secant x. We will get secant square of x, then tan x divided by sine of x. Simplified limit x approaches to 0. Secant square x can be written as 1 over cos square of x. So it will be 2 tan x over. This is 1 over cos square of x. So cos square of x will come down here and sin x as it is. Then open your tan x or the tangent x. The tangent x is sin x divided by cos x. These two terms will come as it is. Now sin x is cancelled with sin x. We got limit x approaches to 0 minus 2 cos cube of x. Now apply the limit. Minus 2 cos of 0 whole cube. We will get minus 2 over 1 cube. So this answer will be equals to minus 2. Question number 4. Limit x approaches to pi sine square of x over cos 3x plus 1. If we put pi in place of x, this pi is basically 180 degree. If we put pi in place of this x, we will again get 0 by 0 form. So we will do what here? We will just use the L'Hopital rule here. So after applying the L'Hopital rule, using L'Hopital rule, we get limit x approaches to pi, sine square of x. Derivative sine square of x will be 2 sine of x and cos of x divided by cos 3 of x will be minus sine 3 of x, and the derivative of this angle, this will be equals to 3 plus 0. We get limit x approaches to pi. 2 sine x cos x is a formula for sine 2x. So I wrote it like this, then minus 3 sine 3x. If we again put x approaches to pi in this function, we will again get 0 by 0 form. So again using the L'Hopital rule, we will get limit x approaches to pi, sine 2x will be cos 2x and the derivative of 2x will be 2 divided by minus 3 sine 3x will be cos 3x and the derivative of 3x will be 3. We will get limit x approaches to pi 2 cos 2x over minus 9 cos 3x. Now use the limit here. We will get, after using the limit x approaches to pi, 2 cos 2 pi divided by minus cos 3 pi. So we will get here 2 into 1 divided by, we'll get 2 minus 1. So here we will get 2 over 9.